Hello, number 3. Use Euclidean algorithm to find the GCD of 162 and 5982. Ugh. But we can do that. 5982 is equal to 162. Then you try things. And I can just see in my head 36. I'm not good. And what would the remainder have to be less than? 162, and it's 150. So then what we do is we take these two, and we go 162 is equal to 150 times what? Without going over, 1, and we'll just have 12 remaining, right? Then I'm going to take this one. Now we're going to have 150 is equal to 12 times, what do you think? Yep, that's gross. Plus 6. And then the last one, and we know it's the last because 12 is equal to 6 times 2 plus 0. Therefore, GCD of 162, 5982 should be equal to 6 using that method. And then we had a way of finding the x and y going backwards. You don't have to do that, but you might want to review that. Yeah. All right, so this one's kind of neat. The relation is R is defined on Z by NRM if and only if the GCD of NM is equal to 2. By finding counterexamples, show that R is neither reflexive or transitive. So come up with a value that's a positive integer where this isn't going to work. Obviously, 2 comma 2 doesn't work. But what could you try? What's that, Abby? Yeah, that's all you have to do. 6 comma 6. What will that be equal to? 6, which is not equal to 2. Therefore, not reflexive for NRM. I would even say MRM. Do you remember transitive, what transitive was? For this was reflexive.
So we have to use ones that do work for R.
Not for the reflexive one, but for the transitive one we will. You're right. So with this one, we're going to do GCD of 4 comma 2, and we're going to do GCD of 2 comma 8. And I'm using the ones they found, but you could come up with an infinite number of other ones. GCD of 4 comma 8. So what's this GCD? 2. What's this one? 2. So is it always going to be 2? Well, this one's going to be what? 4. If A is to B and B is to C, is A is to C? No. Therefore, not transitive.
So is it true for anything then?
If we can find a counterexample, then we can say that this is not true. It's not reflexive nor transitive. By the way, that's on the beginning of proving what? I think it was group, wasn't it? Yeah. So not transitive on NRM. All right. This one, I don't know. This one was kind of weird. Write down the set of solutions for NR6. So what they're saying there is, I think even numbers will work except for multiples of 6, right? So will 2 work? Will 4 work? Will, yeah, 2 and 4 will work. Will 6 work? How about 10? How about 12? How about 12 won't, 10 won't, 8 would work, 10 would work. So what they're saying here, what they did, is you can list them. N is going to be an element of 2, 4, 8, 10, 14, 16. You could list them that way, but probably better, pardon me, better would be if you went N is an element of 2 plus 6N, union N element of 4 plus 6N, right? Because you're, you know.
Also, could you do like N is an element of 2N and then like backslash
Multiples of 6. Love it.
yeah, like N mod 6 or 0 mod 6.
Yep. Where N is an element of integers, I believe. Yep. Natural numbers. I think they had to be positive, didn't they? Yeah, N is an element of the natural numbers. All right, last one. Show that 2 to the N is congruent to negative 1 to the N mod 3. So what I did is I took powers of 2. So what's 2 to the 0 congruent to? 1 mod 3, right? Well, how about 2 to the first? What's that congruent to? 2 mod 3. We could also call it what mod 3? Negative 1. And I'm going to do that. It's kind of neat. 2 to the 2 is going to be congruent to 1 mod 3. 2 to the third, negative 1 mod 3. So do you see a little pattern here? What's the pattern? Yeah, it literally is. When N is odd, 2 to the N is congruent to negative 1 mod 3. 2 to the N is congruent to 1 mod 3 when N is even. 2 to the N is congruent to 1 mod 3. Therefore, 2 to the N is congruent to negative 1 to the N mod 3. Hence, show that an integer is divisible by 3 if and only if the difference between the sum of its binary base 2 digits is even numbered positions and the sum of the binary digits in the odd number position is divisible by 3. This one I want you to study. Express hexadecimal base 16 number. Any ABBA fans in here? Can you sing Dancing Queen? No, you don't have to. Do you really? All right, so for hexadecimal, remember that A is 10 and B is 11, C is 12, and so on. Just to remind you of what those characters represent. So ABBA is 10 times 16 to the third, and then B is 11 times 16 to the second, 11 times, 10, 16, 16 to the first, and 10 times 16 to the 0.
So wouldn't A, if A equals 10?
Great question came up. Are these in binary? And the answer is no, not yet. We're going to change 10 into binary. 10 is 0, 1, 1. 2 plus 4 is 6. So we need another 4. So that's your 10 times 2 to the what power is this going to be? 4. Right. So in base 2, what you're going to do is change this one. This was your 10. 11 is going to be, what is it, 1011 times 2 to the fourth to the second plus 1011 times 2 to the 4th to the 1st plus 1010 times 10 to the 16th. So what's cool about this is 1010 times 2 to the 12th, and this is 1011 times 2 to the 8th, and this is 1011 times 2 to the 4th times 1010. What's so great about 12, 8, 4 is that you literally can line these up. 4 brings this 1101, 1101, 0101. That's your answer for